Okay, so again, this is obviously continuing 5.5. Basically, this is the problem like you'd be given. Okay, we talked about yesterday it has to be written in this form, either like x minus 3, x plus 3, okay? Obviously, it can be any number. There can't be anything in front of the x's. You can't have like an x squared term or anything bigger than just an x. Or you can't use synthetic. You'd have to use long division. So what you're going to notice here is that in this case, you have x minus 3 is what it's being divided by. We have to still remember that if we're missing a term, we put in a 0, which hopefully you're getting used to by this point. It's got to be in order, okay, so make sure you put it in standard form, biggest term down to the constant term. So when we do this, the number that goes here is going to have the opposite sign of this. Okay, that's the easiest way. Instead of teaching you a formula, it's always going to be the opposite sign. So if this is negative, we put a positive number here. If this was positive, we would put a negative number here. Okay? And then we just work our way down. Okay, I'm not going to like re-walk through this. We literally worked this problem just with substitution before. And then when you get down to the end, okay, and you have this number left over, that's your remainder. So you can kind of just ignore whatever they're doing down here. Okay, we're just dealing with this remainder that's left over. So we would have 3x squared plus 5x plus 12, and then plus 34 over whatever we started with, x minus 3. Okay, is how we would write it. Okay, so if you want to write in how we would write this answer, you can write it 3x squared plus 5x plus 12 plus 34 over x minus 3. That's how we would technically write our answers. Okay, that way we're consistent between the long division and synthetic. We always write our answers the same way. And I don't remember if, well, we wouldn't have really talked about this when we did substitution, but this is another thing to point out here. Okay, this started as a cubed term, so we had a cubed, a squared, a first power, and a constant term. So as we list stuff out, that's how they, like, that's still the position they were in. Okay, but if you notice down here when they write their answer, okay, your x's go back into it. Okay, that was the other thing that happened. But it decreases by a power. Okay, so instead of this being a cubed term, it's now a squared term. Okay, and that's because this final thing is the remainder that's left over. Now, on occasion, you might get lucky and it be a 0, but a lot of times you are going to have some sort of remainder left over. Okay, and I think in a little bit, I don't remember if it happens in this section or the next section, but we'll see what happens if it does come out to be 0 and what that means. Okay, so let's start some because it'll be easier once we actually start working one to see exactly what's happening. So synthetic division is 11 through 18, so let's start with 12. Four x squared minus 13x minus 5 divided by x minus 2. Okay, so am I missing any terms? Okay, I'm not missing any terms. And is this in the right form to be able to use synthetic? Okay, it is. So that's always the first two things you want to look at, because if not, you need to fix that or realize, oh, I can't use synthetic. If you can use synthetic is what you're saying? Okay, so if there's just an x and then plus or minus a number. So if it's like x squared, can't do it. X to the fourth, can't do it. 4x, can't do it. Alright, so when we set this up, again, just a reminder, whatever sign is here, the opposite sign is what gets put in the box. So this one's negative, so it's going to be a positive 2 that goes here. And then I'm just going to copy down my numbers. So 4, negative 13, and negative 5. And then following the same thing that we did with substitution, somebody walk me through how I would go about filling this in. Okay, so I'm going to bring the 4 down. Negative 10? Okay. Okay, and again, this over here is your remainder. Okay, you don't have to write this. I'm just writing it just so for reference. Okay, so the way we would write our answer, okay, this was originally a squared term. Okay, and if it helps you just so you don't forget, if you want to come above it and write that this was x squared, this was x, and then that this was just, you know, a constant, you can write that there just so, I mean, it helps you if you want. I don't do that typically just because I'll just look back to the problem and see what it was, but if you need to do that to help you, that's fine. So this was a squared term, so now this is just an x term, so it's going to be 4x. This was an x term, so it goes down one, so now it's just a constant, so minus 5, and then plus negative 15 over x minus 2. And that would be your answer. That's a little easier than long division. And this is a lot more useful in the grand scheme of things. That's why we don't spend a ton of time with long division. We spend a lot more time with synthetic because the stuff that we do pretty much for this rest of this chapter uses synthetic division the whole way through. Let's see. Let's jump down and do 16. Okay, so 16 is x cubed minus 4x plus 6 divided by x plus 3. Okay, so what do we notice about this problem? There's no squared term, so I need to remember to put that in. So you don't have to write it again with the x squared term written in. If it helps you so you don't forget to write it, then you can rewrite it as x cubed plus 0x squared minus 4x plus 6. Okay, if you want to rewrite it, again, I don't require that, but it might help you so you don't forget a term. And are we able to do synthetic with this one? Okay, so how do I set it up? Okay, negative 3 because we're doing the opposite sign from this. Okay, bringing the 1 down. I was like, what is that sound? Hi, Garrett. I was very confused. I was like, is something about to go off? I know. I thought something was going to blow up. I was like, oh, gosh. Okay, so we brought down the 1, so now what? Okay, so that's your remainder. Okay, so then how do I write my final answer? Awesome.
That sounded like a code ritual.
Awesome. So yes, you guys remember to change the x power to be 1 less than it started with. Okay, and we got the remainder out there written correctly. Yes, what's your question?
Oh, I had 2 negative 3 written down instead of 1.
Oh. Yep, that'll do it. Alright, I'm going to let you guys try one now. Okay. Not really. Okay, the biggest thing is always make sure that you have all the terms that you need. Okay, one time I did one of these that was out to the 12th power. That was fun. Okay, so always make sure you have all the terms, and then always remember to check and make sure you actually can do synthetic and that it's written in this form, and then that you do the opposite sign. Those are like the key things to remember here. It's not like hard though, because you just end up like the one I had was like x to the 12th minus 3x plus 2. So I just had a whole bunch of zero terms, which is just a pain to deal with. Alright, x to the 4th plus 4x cubed plus 16x minus 35 divided by x plus 5. Yes. Okay, so you're going to do this one on your own paper, so try that one. Alright, what do we get? Beautiful. We're going to move on, but we're still going to be using synthetic division to do it. We're just going to be using it to do something else. So we'll still be using it, but. Okay, so I'm going to give everybody a minute to make sure they have that like all written down and stuff. Okay, so in the notes, we wrote down the remainder theorem and the factor theorem. Okay, so just as a refresher on this stuff, because we're getting ready to use it. Okay, the remainder theorem says that if a polynomial f of x is divided by x minus k, okay, so something that looks like this, okay, then the remainder is r is equal to f of k. So if I just wanted to find the remainder, I could plug in this number that I use out here, okay, and I could figure out what the remainder is going to be. I mean, it is, but it's a lot faster than actually doing the whole problem. Huh? That's not what we're doing next, but I'm just refreshing on these theorems because we are going to use them. That's just not what we're actually doing next. Okay, and then the factor theorem says a polynomial f of x has a factor x minus k if and only if f of k is equal to 0. So we can verify that something is a factor by plugging in the k value, okay, whether it's positive or negative, okay, it's opposite sign still, and we can see if it's equal to 0 when plugged in, then we know that it is a factor. Okay? So for these next problems, what we're going to do is it says, given the polynomial f of x and a factor of f of x, factor f of x completely. Okay? So this is going to show you how to factor something if it tells you what one of the factors is, and it's not something that you can just factor by looking at it. Okay? Sounds complicated, but again, it's actually not. Okay, because it still just uses the synthetic division stuff. So let's start with 22. Alright, so f of x is equal to x cubed plus 6x squared plus 5x minus 12, and we're told that a factor is x plus 4. Okay? So, what I'm going to do with this one, focus this back in really quick. What I'm going to do with this one is I'm going to still use synthetic. Okay? Because with synthetic, that's going to take this down. First of all, it's going to confirm that this is indeed a factor. Okay, they're telling us that it is, but it's going to confirm for me that it is. And then it's going to take this down to have something that's an x squared term, an x term, and a constant term that I then know how to factor without a whole lot of effort. Yes, factoring completely and synthetic to actually factor completely. So, I'm going to set this up just like I did in the problems before. So if you guys want to do the synthetic division part on your own, we can do that, and then we'll move into the next part. Just don't, once you get the synthetic division part done, don't rewrite it yet. Okay? Well, actually, yeah, you can, because it's going to be a factor. So you should get, if you don't get a 0 in the box at the end, you've done something wrong. Okay? And obviously this one does have all the terms, but again, still, if it doesn't have all the terms, you'd put in a 0. Correct. Yeah, we only do the fraction if there's something left over. Or once you get done with the synthetic, just stop. That's what we're going to pick it up. Alright, so what did we get when we did the synthetic? What ultimate answer did we get? Okay, yep. Okay, everybody got a remainder of 0, right? Okay. Alright, so that puts us here. Okay, x squared plus 2x minus 3. Okay, so that confirms for us that this is a factor. Okay, now they're telling us that it is, but if you were to be given one and it were to ask you, is this a factor, that is how you would check it. If the remainder comes out to be 0, it's a factor. Okay, and that's going to be crucial for the sections coming after this one. Okay, like I don't know if it's the next section, but the section after that, I think, is where that'll be crucial that you can understand that. Because we're going to be checking for all possible zeros of a function. Okay, or all possible factors. The remainder would have to be 0. Okay, so now, again, it wants us to factor completely. We know what one of the factors is. This is something I should know how to factor. What does this factor into? Yes. So that factors into x plus 3 times x minus 1. Okay, and then I bring this factor down, so my final answer is going to be x plus 3 times x minus 1 times x plus 4. No, because if you FOIL it back, it'd be x squared plus 3x minus x, so that gives you 2x, and then 3 times negative 1 is negative 3. From here to here? No, you don't have to. You can do it all as one. I just did that so you see that we factored here and then we brought this down. Normally I wouldn't do it in 2 steps, no. Just factoring this. Okay, and it usually will be something pretty easy to factor. Usually they're not like super ugly, but on occasion you might get a weird one. But it should be something that is factorable, not something that you would need the quadratic formula for. I'm going to say that, and then the next one we're going to do needs the quadratic formula, but it just happens. But like 28 is the worst one. And it's still factorable. All right, let's do another one. Let's do 24. All right. Yeah, you can try if you want. F of x is equal to x cubed plus 18x squared plus 95x plus 150. And the factor that we're given is x plus 10. So go ahead and try to factor this one completely. Huh? Like when we were back doing synthetic substitution? No, you do whatever the number is that's given to you. This is technically speaking, the way this is that in reality, you're finding the 0. So the 0 is setting this x plus 10 equal to 0 and getting the x value, so x would be equal to negative 10, and that's technically what you're plugging in. But rather than telling you to do that every time, it's easier just to tell you change the sign and stick it in the box. Mm-hmm. No, go ahead and factor the whole thing. Give 20 more seconds or so, and then we'll go over it. All right, what do we get? Okay, and just just like as a FYI, okay, if you were to multiply all this back through K superfoil, you would get this to start with. So if you ever want to check and make sure that you did it completely right, then you can go about doing it that way. I'm not going to do that just for the sake of time, but if you were on a test or quiz and you're like, I don't really know if I did this right, that's the way to check it. Any questions about this one? Okay. I was going to say, did you see where you got your negative from? I didn't know if you got the negative from down here or if you had a number up here off. That'll do it. Alright, so we're good with this one? Alright, I'm going to give you one more that's a little bit harder. Okay, like I said, we probably will spend the whole class today working on problems, and then tomorrow you'll have the whole class to work on that and your quiz, and then the quiz makeup stuff, the corrections, you'll turn in by Thursday at midnight. Okay, so basically you'll have a little over 24 hours to work on it. And then that way, if you need to ask me questions, you'll have time to do that whenever you're working on it. Sometimes I'll pull out speed drills and we'll do speed drills. You can use your notes in your book and me, but nothing else. Thanks. All right, I'm giving you the hardest one. Okay? No, they're all good. They're all factorable. Yes, they do. I was very tempted to touch one the other day. I was just afraid I was going to get in trouble. It was very fluffy. It was very fluffy, and it was only 2 months old. It was so cute. I really almost did because they weren't looking. They wouldn't have known. Yeah, they had kangaroo, porcupine, alligator, python. They didn't let him hop around though, so it was kind of sad. But they had him in a pouch because he's only 4 months old. His nose is a little crooked, so his name is Kylo Roo. Supposed. Yeah. Well, the other day they weren't because it was below 40 degrees, and there's a 40-40-40 rule. So if it's below 40 degrees or above 40-mile-an-hour winds, they can't open. Yes. I corrected yours. You should be able to see it now. Yeah, you should be able to see it on Google Classroom. And if not, let me know and I'll print it and send it home with Berkeley. Alright, do this one, okay? So you're doing the same thing, okay, factoring completely. That's always good. I go to the chiropractor and I have to I sit up on a table and I cross my arms like this, and then he takes and he puts his hand on my elbow and then one in the center of my back, and then he takes and lays me backwards and pushes down, and it's like he's like, breathe out, and I'm like, I can't. The most terrifying thing is they do a lot with my neck, so he'll crack my neck, so he turns my head sideways and then he tilts it and he'll kind of sort of crack it, and I'm like, oh, he's done, and then he's like, and I'm like, ah. I'm so scared every time he does it that I'm gonna become paralyzed. Yeah, it's it works, but it's terrifying. All right, what do we get?
Nothing. 3x plus 4, x plus 1, x minus 5. What? Nice, firstly, I have 3x minus 1. Can you just
I got 3x plus 4.
No, because you have to have it equal 13. Well, it's a positive 4.
All right, so you should have gotten down to this point. Okay, so 3x squared plus 13x plus 4. So I need factors of 3 times 4 that give me 13. So that would be 12 and 1. Okay, so it doesn't really matter which one you put where. You're going to get the same answer either way. But I just put the 1 with the 3 and the 12 with the 4. So I pulled out an x here, so I was left with 3x plus 1. Over here I pulled out a 4, so I was left with 3x plus 1. Again, these have to match. If these don't match, it's not right. So then x plus 4 times 3x plus 1 times x minus 5.
That was fun.
Yeah, because that's not going to come out to give you the same answer. I factored. 3 times 4 is 12. I need factors of 12 that give me 13. And that would be 12 times 1. Because I'm factoring by grouping. Alright, so the last thing, okay, it says to given polynomial function f and a 0 of f, okay, find the other zeros. So a problem looks like this. Okay, f of x is equal to 4x cubed minus 25x squared minus 154x plus 40. And it's told us that their 0 is 10. Okay? So, going back to what I was showing Ariel earlier, okay, when she was asking that one question about if you always change the sign of it. Okay, in this case, you are not changing the sign. Okay, it is already changed for you. Because what this really means, because it says it's a 0, is that x is equal to 10. So the factor, we'd have to move the 10 back over. The factor would be x minus 10. Okay, so that's why it's already given the correct sign. Okay, so this is a 0. So I want to find the other zeros. So if I was asked to find the zeros of this one, you set each piece equal to 0 and solve for x. So you're going to have 3 zeros. Okay, now if it's repeated, you only write it once. Okay, you're not going to write it twice. I think, yeah, they don't write them multiple times. I'll tell you 33 and 34 don't come out pretty, so that's one where you'd have to use the quadratic formula, so you won't have one like that. I'm going to give you these ones that are easier. Okay, so let's look at this one, and hopefully we'll have time to do one more. Okay, so now I just take this 10 and stick it out front. Okay, because like I said, the sign was already changed for us because in reality this was the factor. So this is how I would make it look like the other problems that we've done. Okay. So then, again, obviously I'm not missing any terms, so that's good. So 4, negative 25, negative 154, and 40. Alright, so just for the sake of time, we're going to walk through this one together, and then I'll probably give you guys the other one to attempt on your own, and then we'll go over it really fast before class is over. And then tomorrow, well, and I'll probably write down what problems you need to do. So if you want to start them, so that way tomorrow you can work on your quiz corrections, that's fine. I don't care. You should have plenty of time tomorrow to do it, but... Alright, so bringing down the 4 times 10 is 40. 40 minus 25 is 15. 15 times 10 is 150. Negative 4. Negative 40. And 0. Okay? So this is in fact a 0 or a factor. Okay? This still needs to be 0 for these. Okay? So now I'm left with 4x squared. Yep, so 4x squared plus 15x minus 4. Okay, so now I need to factor this. Okay, so this is one where I need 4 times negative 4 to give me 15. Okay, yep, so it's going to be 16 minus 1, so it really doesn't matter which one I pair with what. I'm going to just throw the 16 out front so I have my positives together and my negatives together, but it's totally up to you. It does not matter. Okay, so 4x squared plus 16x minus x minus 4. Yes. Now I'm factor by grouping, okay, from the last section. So I'm pulling out a 4x, and I'm left with x plus 4. And then over here I'm going to pull out a negative 1, and I'm left with x plus 4. So then my factors are 4x minus 1, x plus 4, and x minus 10. Okay, so that gets us to the step we had before. We were already told that 10 was a 0, so we don't need to rewrite that one. We just need to write the other ones. Okay, if you do write it, not like it's wrong or anything. Okay, so I set each piece equal to 0, so 4x minus 1 equal to 0, and then x plus 4 equal to 0. So my other zeros are x is equal to 1/4, and x is equal to negative 4. Okay, and then like I said, my final 0 is x is equal to 10. So these are the same, so it's repeated, so we only write it once. Yeah, so those on the outside. So it's the outside stuff times the inside stuff. And if you need a refresher, just look back at the factor by grouping notes that we did. I think it was 5.4, section 5.4. It says to find the zeros. Given polynomial function f and a 0 of f, find the other zeros. Okay? All right, we have a few minutes left, so I'm going to give you guys the one to try, and then I'll write down what your homework is. And then, like I said, if you want to start on it tonight, you can. And then tomorrow, you'll have the whole class period to work on these problems. That way, if you need to ask me questions, you can, and I'll try to walk around a little bit. And then you'll also have time to do your quiz corrections, and that way, if you need to ask me about any of that, you can do that as well. So 32, so this is the one you guys are going to try. So same instructions as 30. F of x is equal to 3x cubed plus 34x squared plus 72x minus 64. And the 0 that we're given is negative 4. Yes, so these ones you leave the sign. Y'all probably don't want my hand frozen on the screen, do you?
Why not?
It does. Okay, I'm just going to give about 1 more minute just because we need to go over it before class is over because I want to make sure it's done. Alright, just because there's only like, well, actually, keep working. I'm going to write down what the homework is going to be. And then we'll go over it really fast. I already gave you guys problems yesterday for long division, right? Okay. That's what you'll work on in class tomorrow, yeah. So you'll have all class period tomorrow and, well, all class period tomorrow to work on this and the quiz corrections. And quiz corrections, you don't have to do it. I just would recommend it because you probably want to get your points back. I don't remember. The highest was an A, but. Yeah, that'll be added onto here all as one assignment. And you'll submit it all together. Alright, let's go over it really fast. Alright. Alright, so you should have gotten your synthetic part. Everybody okay with the synthetic part? Okay. So it would have been 3x squared plus 22x minus 16. Okay, I did the factor tree to try to figure out what I needed. I ended up needing 24 and negative 2. Okay, and then you went from there, factored it. I can put this back up tomorrow if you guys need to like get it written down. But your homework is at the bottom if you want to write it down, or I can, like I said, I'll stick it back up tomorrow if you need it.